Okay, hello. So let's see chapter 11.1 motion. Okay. So we will now start talking about motion. Okay. So let's see. We'll start talking about the 11.1 motion. So I've already uploaded this for you. This one. Yes. So please complete this exercise. And this exercise is about chapter 11.1 motion. And so you have to scan this QR code or press this link to watch the video. Okay. And hand in this worksheet and using a piece of A4 size paper. And then please upload your work to Google Classroom before 26th of March at 4 o'clock. Okay. So let us go back to here. Okay. So 11.1 motion. So part A, so we'll first learn about distance, time, and speed. So take a textbook, turn to page 159. Okay, so do you know what the fastest object in sport is? The answer is the shuttlecock. So do you know how fast it can move? So shuttlecock, which means 羽毛球，但唔係即係踢問題羽毛球，係即係呢隻球啫，球。Okay. Shuttlecock. Okay, so to answer the question above, we need to first learn about speed first. So speed describes how fast an object moves. 速度咧就係去describes 即係去係啦 how fast an object moves， 呢個物件係究竟佢速度有幾快，稱之為速度。So the speed of an object is the distance traveled by the object per unit of time. So the unit of the speed is the meter per second, the kilometer per hour, km per hour, or ms. So it's basic knowledge. So for example, our walking speed is about 1.1 meter per second or 4 km per hour. The faster an object moves, the higher its speed. 當你話嗰個物件好快速咁移動嘅時候咧，佢個速度亦都會快嘅喎。Okay. Okay, so turn to the next page. So an object's speed may change while it is traveling. So if we know the distance traveled by an object during a period of time, we can find the average speed of the object using the formula below. OK， 咁我哋就話啦，其實咧一個 object 咧就佢嘅速度咧就有機會轉動，當佢喺度 travel 行緊嘅時候。咁如果我哋就知道當個距離咧，我哋就要揾出佢嘅平均速率。咁平均速率點揾咧？就係 distance time 就係距離除時間 distance per m over time. Okay. So this one is important. Remember it. So let's see this. Let us see how to use this formula in the following example. Okay, so an MTR train takes 4 minutes to travel a distance of 4 kilometers from the Admiralty Station to Ocean Park Station. So find the average speed of the MTR train. So you can see that the time you need is 4 minutes. And it's a distance of 4 kilometers. So I've already told you about that. It should be the distance over the time. So which is called the average speed. Average speed. 平均速率, okay? So you can see that this is the solution. So the distance is 4 kilometer, which means 4,000 meters. So 10 km per 2m times 1,000, and the time is 4 minutes. 4 minutes times 60 seconds, which means 240 seconds. The average speed is 4,000 meters over 240 seconds. So which the answer we got there is 16.7 meter per second. Okay, so no problem, right? Okay, so next page. So we don't do this. So to represent the motion of an object, sorry, with the key point, okay? So student is the distance, speed. Speed is the distance traveled by an object per unit time. It can be measured in meter per second, which means ms, or kilometers per hour, km per hour. Okay, so let's learn more about the distance time graph. So to represent the motion of an object, so we can draw a distance time graph for the object. So let's learn how to draw one below. So some students were doing a project to study the motion of birds. They were at different positions between bus stop A and B and recorded the distance traveled by the bus at different times. They found that at time 0 second, the bus was at the bus stop A and started to move. 喺0秒嘅時候嘅巴士咧，仲喺個站 A 嗰度就開始喐啦，行啦。好啦 ，so in the time at 10 seconds, the bus has traveled 150 meter， 行遲咗150米。So in the time 20 seconds, the bus has traveled at 300 meter. So at the time 30 seconds, the bus stopped at bus stop B, that is 450 meters from the bus stop A. So at the time of 40 seconds, the bus was still at bus stop B, 仲喺個站 B 嗰度。So we call about distance time graph, which means it's the 距離時間關係線圖。咁就知道，咦，原來佢由幾多分鐘開始或者幾多秒開始行咗幾多距離去到邊度，咁就用呢個距離時間關係線圖去表示嘅。Distance time graphs, okay? So turn to the book, page 163. So please bring the table below to record distance traveled by the bus at different times from the 0 to 40 seconds. So from the 10, the bus has traveled 150 meters. From the 20, 300. From the first 30 seconds, they have 450 meters. And also 450 meters. Okay, so draw a graph so you draw it by yourself. I don't do it. So suppose that the students use one of the methods below to represent the motion of the bus. Method 1, writing a description. Use the table as in step 1. Method 3, drawing a graph as in step 2. So discuss with your classmate the advantages and the disadvantages of using each method to represent the motion. So you discuss. I give you 1 minute to think about this. So you can think about it. Okay, 1 minute. Oh, sorry. So some technical problem. Oh, I don't know why. Ai. So you can refer to textbook page 164 first. Represent by using a distance time graph. So a distance time graph shows the distance that an object has traveled at different times from time 0 second. For example, from the distance time graph of a car in the figure 11.3. So we can find that the car has traveled at 160 meters at that time. So yes, here. I've already give you have 1 minute. So I will give you some ideas. So in the method phase, drawing a graph will be much clearer to see that the distance time graph for the car. And using a table is also okay. And so 1, 2, 3, I will also suggest is also okay. Okay. So yes, this one. Such the distance time graph shows distance that an object has traveled at different times. Okay, so okay, and so besides the distance traveled, we can obtain other information about the motion of a distance time graph. Let us investigate this further in the experiment 11.1 below. So let's do this experiment first, and then I'll ask you some questions. Okay, so let's go back to your book. So from the experiment 11.1. So from the experiment 11.1 below, yes. So we can see that the distance time graph of an object has different shapes in its different motions. 即係就知道咧，我哋當我哋睇到個 distance time graph 嘅時候咧，佢哋原來個 object 咧就唔同個樣喎。咁點解 different motion？點解咧？就係話 when the object is the rest，is at rest，即係一休息停低咗。The distance time graph is a horizontal line，係一條平線長線嚟嘅。So when the object moves at a steady speed, the distance time graph is a straight line with a slope. The higher the speed, the steeper the slope. 當速度越高嘅時候咧，個 slope 就會 steeper 咯喎。OK。So this is our distance time graph. Okay, so let's take a look at checkpoint 11.1. Okay, so write the truth for the true statement and false for the statement. 1 unit is of speed is SM. What's wrong, right? It should be M. It should oh, oh, oh. It should be M per S. Is the horizontal line? If the vertex is rest, true. True, right? Okay, so the distance time graph on the right represents the motion of the car from time to 0 to 25 seconds. So what is the distance traveled by the car in the first 10 seconds? It should be 100 meters. So describe the motion of the car from the time 0 to 25 seconds. So呢度開始咧 is a rest, is at rest, okay? Here is in rest. And here you can see that it is the steeper, it's steeper and steeper. So you may say that the motion of the car is steeper and rest. Okay, so this is the checkpoint 1. Okay, so in the previous sessions, we learned some concepts about the motion of the object. Okay, so let us now look at the type of the motion called uniform motion in the experiment below. Observing a uniform motion. 我哋咧叫 uniform motion 咧係均速運動，咁究竟係咩嚟嘅咧？一齊睇一睇啦。
Okay, I'm gonna call now. Set up the apparatus as shown. Motion sensor, data logger and computer, glider, air track. Air pump. Switch on the air pump. Give the glider a short and gentle push. Observe the glider's motion. Look at the distance time graph of the glider.
Okay, so let's go back to your book. Yeah, okay. So in the experiment 11.2, so you have studied a uniform motion of an object. So an object is said to be a uniform motion when it's moving at a constant speed in a fixed direction. For example, the people standing still on an escalator. Okay, so if an object is moving at a changing speed or changing direction, we can call that this object is the uniform non-uniform motion. 非均速運動啊。 呢個係均速，呢個係非均速。OK，so for example, when a car is braking 剎掣 it is in a non-uniform motion because its speed decrease 速度就下降咗。Okay, so activity 11.3. So identifying the motion of a bus at different instance. 我唔講住呢個 so I don't talk about this. You do it, you look it by yourself. Okay, so key point, an object is in the motion with the constant speed, which means it is a uniform motion. And this is the non-uniform. Non-uniform motion. Okay, so let's we cover this chapter 11.2. So in which of the following situations is our objects in the uniform motion? Which of them is the non-uniform motion? So what are 1, 2, 3 instances provided? So give you 2 minutes to do it. Okay, give you 2 more minutes. Okay, time is up. So this is the answer. So for number 1, people standing still on an escalator, it should be the uniform motion. So racer started to run, it should be the uniform motion. Ping pong ball being hit by a player, it should be the non-uniform motion. Okay. So travelator, which means 行人輸送帶. Okay. So this is the end of the chapter 11.1. So I will upload this video, and also today we have 2 homework. So number 1, so please complete this chapter 11.1 motion, this worksheet. If you haven't completed, please complete it. Number 2, I will open the quiz. It's called a Google form. It should be chapter 11.1, 11.2. Fourth, Google form. It is for your preparation. So this will be on the next. It'll be on the next Monday. So this is also your this is called force. Okay, so I will do this Google form now. So please watch the video about the fonts. And complete 5 MC questions in this Google form. So wait a minute. So this video will be ended. So please, you can stop the video. Okay, so this video will be ended. Bye bye.